My dear children, today I came to explain you the last type of hybridization related with the sulfur atom, right? Then, do you remember, up to that I had explained you four types of hybridizations in detail related with the carbon atom, sp3, sp2 and sp, right? Then my last day video I was explaining you sp3d type of hybridization related with the phosphorus atom. Not in detail, because I told you that we must know the shapes of orbitals during the explanation of the type of hybridizations. But you know that according to our A-level syllabus, we must know only the shapes of S-type of orbitals and P-type of orbitals, not the D-type. Therefore, not need to know in detail the sp3d type hybridization of phosphorus, and today I will be going to explain you the new type of hybridization related with the sulfur atom, it also, right? Then, what is the atomic number of sulfur? 16. Ground state configuration, ground state configuration 1s2, 2s2, 2p3, 2p6, 3s2, 3p4. Altogether 16 electrons. The outermost orbital is third. Energy level is third. 3s2, 3p4. 3s2 has filled with 2 electrons. 3p4. These are the 3 orbitals. Dumbbell shape. 1, 2, 3, 4. Out of the 3p orbitals, 1 gets filled. So as in the phosphorus atom, the third principal energy level has 3d orbitals also. Then we must know that 3d orbitals are present here. Right? How many orbitals? 5 orbitals. I have drawn 1, 2 out of 5. Not need to know the shape. Right? Then this is the ground state configuration. According to that configuration, sulfur has the possibility to form 1, 2, only 2 covalent bonds. Right? Then it becomes excited state, transferring 1 electron of the p orbital out of the filled orbital, one electron transferred to the 3d 1 orbital, 3s electron also transferred to the other 3d orbital. Then after the transference of these 2 electrons from 3s and 3p, the configuration becomes 3s1, 3p, 1, 2, 3, 1, 1, 1, 3p3, 3s1, 3p3, 1 in each, and 3d becomes 1 electron at the first orbital, second electron at the other orbital. 3d2. 3d2. Then at the third energy level, after the excited state, excitement, there are 1, 2, 3, 1, 2, 3, 4, 5, 6. 6 orbitals with 1 electron in each. 6 electrons in 1 electron in each, connected with 3s, 3p, 3 and 3d2. But you know that after the excitement state, they are original energy levels. That means 3 energy levels and 3 shapes. 3 shapes. Spherical, dumbbell, that unknown shape. 3 shapes, 3 energy levels. After that, at the hybridization state, all the 6 orbitals come together to the same energy level with the same shape. So, they become to the hybridization. That type of hybridization can be explained as S. S P3 D2. All are in the third energy level. sp3 d2. Altogether, 6 hybridized orbitals are formed which are identical each other. This is the new type of hybridization of sulfur atom. Right? After the hybridization, there is the sulfur nucleus. Out of the 6 orbitals, 4 are arranged like this. 4 are arranged giving the square shape, plane square. All the 4 orbitals are at the same plane, square plane, and the other 2 perpendicular to that plane. Perpendicular to that plane. This is the arrangement. sp3 d2, sp3 d2, sp3 d2, sp3 d2, sp3 d2, sp3 d2. 6 orbitals are arranged. 4 orbitals are at the same plane, square plane, perpendicular to that plane. Other 2 are arranged. So, I'll show you a model of this arrangement like this. These are the 4 square plane, 4 orbitals, 1, 2, 3, 4, square plane, perpendicular to that plane, 2 orbitals are arranged like this. Then that whole arrangement, how many angles here? How many angles? All are 90 degrees. 1, 2, 3, 4. At the same plane, 4 bonds, they arrange 90 degrees to each other. 4 angles. Then This is perpendicular to all the four bonds. There are four angles 90 degrees. Here also four angles 90 degrees also. Altogether 12 angles, all are 90 degrees. The whole arrangement, if we connect these atoms, so this is the square plane. On the square plane, pyramid with the four faces. It is the square pyramid. Below also square pyramid. So there are two square pyramids with the common square plane. So this can be explained as in the phosphorus. Do you remember? In phosphorus, trigonal bipyramidal. Here, not the trigonal, square plane, square pyramidal. Square pyramidal, square bipyramidal, square bipyramidal. Right? But this is explained as giving a simple name. So the whole arrangement has how many phases? 1, 2, 3, 4. That pyramid has 4 phases. The other one also 4 phases. The whole arrangement has 8 phases. 4, other 4. 8 phases, whole arrangement. So it is named as octahedral arrangement. Octahedral arrangement. Right? Then I'll show you. This is the square plane, octahedral arrangement, octahedral, right? Octahedral arrangement. Therefore, sp3d2 hybridized atom shows the octahedral arrangement with the hybridized orbitals. Then that sulfur atom has 6 orbitals hybridized. All are identical. Now we are considering the molecule. SF6 sulfur hexafluoride. Sulfur atom here, this is the nucleus of sulfur. It forms 6 bonds with fluorine atoms 1, 2, 3, 4, 5, 6. Then fluorine has the 9 atomic number. 1s2, 2s2, 2p, 5. 2s2, 2p, 5. Second energy level has 3D arrangement of the dumbbell shaped orbitals Py, Px, Pz. 3D arrangement. 5 electrons are filled. 1, 2, 3, 4, 5, 5. This orbital has only 1 electron. That fluorine atom has, out of the 2p 3 orbitals, 1 has unfilled. So this orbital can bonded like this with the sp3d2 hybridized orbital of sulfur. This is the p orbital of fluorine. Linear overlapping, forming sigma covalent bond. So it is clear that similarly with all the other hybridized orbitals, it is possible to form 5 sigma covalent bonds with 5 fluorine atoms. Then this is the 5 fluorine atoms with this one 6. This is the molecule of SF6. Right? Then it is clear that I think for the formation of sulfur underwent sp3d2 hybridization before the formation of SF6. Right? My dear children, now from these videos, I had explained you sp3, sp2, sp related with carbon atom in detail. Tetrahedral, trigonal planar, linear. After that, not in detail, phosphorus for the formation of PCl5, sp3d, sulfur for the formation of SF6, sp3d2. This one gives the trigonal bipyramidal shape. This one gives the octahedral shape. These are the 5 types of hybridizations related with your A-level syllabus. Right? Then you must know these 3 in detail then. sp3d and sp3d2 related with phosphorus and sulfur. Right? Then in my future videos, I hope to explain you in detail what is the type of hybridization of the central atom of a molecule. Type of hybridization out of these 5. And according to that type of hybridization, what is the shape of that molecule in the space? There's a relation between type of hybridization and shape of the molecule. To study, you must know well the type of hybridizations and their particulars. Right? Then I hope to teach you, to present you by my future videos this subject matter. Then I want to tell you, my dear children, I am working in an institute related with the education field, right? Then I also participated with the paper marking curriculum also. Then I have the ability to help you according to your exam for the A-level, for the successful to be the results, right? Then please be with me. I will be going through the whole syllabus with the different sections of the chemistry. After the molecules, I hope to come to the S block, P block and D block, so the block elements. Then after that, I will go through the last unit also, up to the last unit also. Right? My dear children, I will be with you always up to your final results. Right? Then subscribe me, please be with me. Thanks, lot of thanks for you. See you again. Right?